that paper title, which is really the system Skyhook. So this is a third signaling channel. Oh, sorry. So this is a third, is it? Yet a third signaling channel. So we're going to briefly go over this because we've just seen it twice. So users who want to access censored content might need to go contact a bridge distributor in order to get a new bridge. We're going to call that a signaling connection. And then they'll use that data to go connect to their hopefully unblocked bridge. The main points here are we're thinking of signaling connections as being somewhere between 1 to 4 messages, maybe ideally 2, a request and a response. And the key point is that we want our signaling channels to be publicly addressable in the sense that they don't require any shared secrets between the client and the bridge distributor in order to remain unblocked. Right, so that way you don't have a recursive bootstrapping problem where you have to signal for getting your signaling channels. And as stated last time, higher latency is acceptable. So this work was inspired by Cloud Transport that is about 10 years old now. And it's sort of a refactoring of the design to reduce user burdens. In particular, Cloud Transport had the client running the AWS account, which was great for denial of service prevention because you would DOS yourself since you're the one paying for it, but very hard to use in terms of you have to go register for an AWS account and pay for it and everything. So, it was a lot more burden on the user. And the second half of this talk is going to talk about the fact this was implemented as a raceboat transport and user model, which we'll talk about later, which will be presented at PETS in 2 days. So basic operation, very similar to the last talk, except instead of using Google PubSub, we're going to be using Amazon S3 buckets. So you're going to start with a public bucket that is publicly writable, but not publicly readable. So the server is going to create that bucket and broadcast that information out. And then the client is going to load that information in order to create their side of the link. And then they're going to create their own, they're going to sort of assert their own new bucket ID. They can't actually create it because they don't have an account. They're going to generate it, they're going to package it up and send it with the sort of hello request to the server. And the server will get their request, presumably for a bridge or whatever other information they want, as well as this sort of assertion of, I would like to use this other bucket ID to talk from now on. And then the server will go ahead and create that bucket and object and make it they'll make one object publicly readable, one object publicly writable, and they'll just poll the publicly writable one. The client will poll the publicly readable one, and whenever the server sees there's new information, it'll sort of increment to the next object. So this lets you sort of set, rather than one publicly writable object in case the client's going to need to send X messages before the server checks, we're actually going to make a series of objects publicly writable that are sort of a hash chain. So object A, and then the hash of object A is the next one you can write, and the hash of object A is the next one, and so forth, to allow for sort of bursty communication if you need it. Doesn't really come up if we're actually in the signaling channel case where we just want like one message request and one message response, but it does generalize to sort of a longer lived connection if you wanted to. I'm not going to get into this unless someone has questions. So there was a demo, but my laptop is offline, and of course it is cached on YouTube, so we'll revisit that at the end if we have time. Okay, so it works. You can trust me. We'll alt-tab to the video if we can. But now I want to talk a little bit about what I mentioned before about implementing this as a transport and user model in the Raceboat framework. So again, we'll talk about Raceboat more at PETS in 2 days, so I encourage you to come. The idea is it's sort of like pluggable transports in terms of being sort of a generic way to manage channels that lets the application not know so much about them. But one of the pieces that we built for it is this idea of decomposing application tunneling channels. So typically, if you're going to create a new application tunneling channel, especially if you don't assume you have encrypted traffic, so you need to do some sort of steganography. You end up sort of reinventing the wheel a lot, rebuilding the same software over and over if you're a different research group. And so we are trying to produce a sort of modularized version where if you have one good idea for one of these three components, a user model or an encoding or a transport, you can just build that and then publish it, and you can use other people's versions of the other components, and now they can use yours, and we can sort of mix and match everything and get more productivity. So briefly, the user model, the idea there is that's controlling sort of how you interact with an application. So in this case, it's like, how often do I poll S3? How often do I potentially post stuff to S3? Another good example would be, I think last year, the PETS paper, Learn to Behave, that had the Raven email channel. That was all about building a user model that looks realistic in terms of how often it's sending emails and what size those emails are. So the idea is abstract that out, and now if you have a censorship area where the sensor is actually doing sort of advanced analysis of how you're interacting with an application, then you can sort of, in isolation, do some data science and make a good model that will pass as human, or avoid new rate limits on a service, things like that. The transport is about actually interacting with the application. So in this case, one of the modules is using the AWS SDK. The other one is sort of using unauthenticated curl requests. In a different channel would be like interacting with an email server, or interacting with a social media server, whatever your channel uses to sort of actually convey bits. And then lastly is the encoding, which is pretty straightforward. It just gives you content. So your transport says, well, I need some content to post something on social media, or I need some content for an email I'm going to send, and I want it to look normal. And so you dispatch it to the encoding component that will do some sort of stego to do that, right? So if you want an image, you should use an image encoding, and you ask it for an image, and it should generate it for you. And if you have data to send, then it will stegographically encode it in that data. And on the opposite side, when you receive stuff, you dispatch it back to the encoding and say, hey, can you find if there's any hidden data in here that I need to extract? And so in this way, if you make a new cool stego encoding, you don't have to go implement your hacky transport and user model in order to do an evaluation and get people interested. You can just publish the encoding and reuse other people's transports and user models, and hopefully things get sort of easier to iterate faster. So this is the sort of more complicated quasi-API level design. And so I'm just going to briefly talk about this to try and illustrate that it's not as complicated as it might seem. So on the left here, we have a sender. And so the user model is in green, and all it does is issue a timeline of actions. So in this case, for Skyhook, it would be like action poll S3, action post something to S3. Sort of matches up with the transport to some extent. The transport in blue is just going to do actions, and ahead of time it's going to look at an action and say, well, do I need content for this action? And if it does, then it's going to say, okay, I need content, and it needs to be this type. We use MIME types, and that dispatches to an encoding to say, okay, well, I need a JPEG. I need some text of this size, that kind of thing. And so if an action needs content, then we, ahead of time, go over to the encoding and say, okay, we need to encode some bytes. So we need some content, and if there's data, if there's actually secret data to encode, like I want to say, give me a bridge, please, then the encoding is responsible for taking those bytes and converting them into whatever type of content it produces. So I put it in the least significant bits of the JPEG, or I synthesize an image through a neural net that encodes the data, or whatever it is the encoding does. And then it hands those bytes back to the transport, and the transport goes and, in this case, pushes it to S3, or does whatever the transport does. On the opposite side, sort of the reverse process. So the transport gets some sort of action to poll for data, or somehow receives data, and then, assuming it got data, it will dispatch it to say, hey, try and decode this, see if there's data, see if there's secret data in there, and then the encoding just receives the package and forwards it up to the application. So I think I accidentally sort of went over these details, but basically the encoding I think is the simplest one. I would imagine any sort of Stego or other sort of content production code would be able to fit in these APIs pretty easily. You just need to encode bytes or decode bytes. Transport, again, so it just defines a set of actions that it wants to be able to execute, and whenever it receives an action, it just needs to go execute it, and if it needs content for the action, it needs to describe what the content it needs for the action is. And then the user model is just saying, issue a timeline of actions, potentially update that timeline. And there's a feedback mechanism for the transport to tell the user model about stuff in case it needs to. So for example, oh, you've hit the rate limit for this API. You should be designing around that, but maybe, or you got a message that your request failed because you're going too fast. So the user model can then adjust and slow down its timeline if it has that sort of advanced behavior. So again, the idea is that these components are interoperable by using these APIs. And so all you have to do is get an executable version of somebody's component and throw it in a JSON file and just run Raceboat with it, and you can use it. So for instance, Skyhook has two transport components, the public user one that is unauthenticated, the account holder one that is using the AWS SDK for all the authenticated stuff, and a user model, and it doesn't actually have an encoding component. So we pull the encoding component from a different plugin by listing it. In this case, we don't care because it's all encrypted, so we're just going to use this no-op encoding component. But you can just swap in that string with some other name of an encoding component that gives you, let's say, images, and now, okay, I can upload images that use the Stego algorithm to S3. And so, if you suddenly go to a new environment where it's like, oh, my TLS is being broken, and I'm worried about people reading what it is on S3 that I'm downloading, then maybe I should swap in my image encoding or some other encoding to make it less apparent that I'm just downloading, bridge requests. So the main interoperability issues are the transport and the user model sort of have to agree on what it is they do. Right? The user model issues actions. The transport has to know what those actions are. Doesn't help to tell the S3 transport to go read an email. But aside from that, the idea is that these can sort of be swapped pretty easily in between, and that you don't need to go tell me or some Raceboat developer to go add this code to the Raceboat code. You can just build your plugin, publish it, put it in, edit some config files, and you're good to go. So we can try command tabbing to a QuickTime tab. I have the video there. Yeah, that laptop. One more. And hit play. Did we hit play? All right, so this is running it. So this is an AWS server. This is going to run Raceboat, and I'm just highlighting different parts of the command. So this is telling it what channels I want to use, and then some parameters for using Skyhook, so it just needs to know the region. This is the publicly known address, which is fine to publish. And so then we're going to run it, and then we're going to hop over to the client, which is on a laptop. We're going to run a Raceboat command to send receive command, so it's going to send one request and expect one response back. Again, specifying the channels and the region and the same address that the server had. And then we're going to run it. And so this will be posting something to the public bucket, requesting a private bucket, reading from it, and there's your bridge address. In this case, it's just reading bridge addresses from a pre-configured file. Again, as the last talk said, orthogonal to the channel is the idea of how do I distribute bridges in a more intelligent manner. This is just showing the AWS buckets. So we have a new bucket we've created. It's going to last for around 10 seconds after the response finishes to give time for the client to fetch it. And then we're going to, I guess we're running it again. So then you'll see the new bucket disappear because we delete it and clean up. But that's pretty much the talk. So questions?
Let's thank the speaker for an excellent presentation. And yeah, if there are any questions. It will come from the back.
Hey, thank you so much. So I think common to the last talk and this system is that there's like some publicly writable bucket or channel. How scary is that? Like, are you worried that denial of service vector is like writing junk to that bucket a lot, or are there ways to prevent that?
Yeah, so I mean, it's pretty much the same as the SQS talk at the top of the section, I believe. I don't know if the pricing is a little bit different, but yeah, basically the publicly writable object, yeah, you could spam it. So given that in this case it's being hosted by AWS, we're not necessarily concerned about like them overlowing the network connection, but the actual dollar cost could be an issue. So yeah, there's a mitigation for that. Well, there's a partial mitigation. So you could use an API front end, but then you can't connect to the generic region address. You have to connect to a specific gateway, and so then you can block the gateway. So it's sort of, yeah, get rid of one problem, add another.
Okay, I'm starting to speak. Okay, great. Hey, Paul.
Hey.
Thanks for the talk. I appreciate you adding modularity to this. I think that's something that will help the community move forward, so thanks for that. I'm curious if you could say a little bit more about the dependencies between the different modules. It seems like you probably wouldn't want to mix specific modules with other modules, right? Like if I have an email user model and I mix that with, like, can I mix that with something that's like not gonna make sense to do that?
Right, so the user model and the transport have to be compatible, right? So the user model issues string action names, and the transport has to know what those are in order to do them. Like if the Skyhook model gets or Skyhook transport gets an action to send an email, it doesn't know what to do with that. So there's that level of compatibility, and then yeah, at the more semantic level, there's I wouldn't want to just string replace the Raven user model with post and pull to AWS at the timings that it made sense to post and pull to email. The idea with user model and transport modularity is there's some cases where I think you could directly swap between them if the services are very similar. So if I had one social media service and then maybe the user behaviors look similar to another one. So if I've done a bunch of work to look realistic on one, maybe I can transfer some of that to another one. There's also the one-to-many transport to user model case. So if I have a transport and I need to look like a real user but in different ways, like maybe different regions have different usage patterns that I need to match, then this provides an easy way to have like multiple user models that you can pick among for the same transport.
So you're saying if a lot, so I'm guessing, do you have any defaults that you built in? And then also, I guess you're imagining that the community is gonna build different modules, and over time it'll become easier to only build one of them because, oh, the other one already exists for this sort of transport that I'm trying to develop.
Yeah, so the user models in particular, we don't have a lot on, right? Basically, we have a default model that's mostly performance and not hiding, and then I think we could use the Raven one for email. But otherwise, we don't really have, we haven't done the sort of the research to find what user models do you need. I mean, I think as most of the talks so far have been, it's like, the sensors aren't really doing analysis at the level of user behavior, so that hasn't been a demand so far. We are going to be releasing, hopefully in about a month or two, several more channels that have been broken into these components. So.
Unfortunately.